Hi. We're going to try this whole Gotek thing again. Because I read some of the manual for Flash Floppy, which I probably should have been doing in the first place, one would think. But you're going to accuse me of thinking clearly at this point? That is a spurious accusation, if I do say so myself. So anyway, I think I understand how it's supposed to work now. I'm going to make a Flash Floppy config file and try this whole thing again. Okay, bye. And hello. Yeah, so there's my face. Gotek, Flash Floppy, all of this fun stuff. Fun. We're having fun. Good evening, Werewurm. So, yeah. Here's the thing. Werewurm says, have tested my own Gotek now. Are you using Flash Floppy? Cause Cliff Cheney says, all of this fun. I am having fun. I wouldn't do this if I weren't having fun. And that's why some episodes I just give up. Let's get this laptop out of the way, because I'm not going to use it. And let us pull the Gotek drive and put it over here. And I think what I want to do is... Apparently you have to set a jumper, firstly. I don't think it really would affect us too much, but you have to set a jumper or configure a thing in the configuration file to make this thing work in IBM PC mode, because there is a pin that is non-uniform, and apparently that's not the default. So I don't think that's what was screwing us up, but firstly, I'm going to get rid of this horrendous thing, because that was a mistake. And then I do believe what I was reading about Flash Floppy was, you can do it, come on. You can, I bet you can delete it. Oh, Werewurm says, no, I wrote a comment on your poll for BOS. Let's see. Let's check the old community tab. YouTube.com. And you can see all the weird stuff that YouTube suggests my Track Zero account, which I don't actually use for watching videos. Oh, look, there it is. I would not mind some BIOS, said Werewurm. Regarding the Gotek, I installed mine for the first time, and it somehow reserves all the space on the USB stick except for 1.44 megs. The files on this remaining space will be the files on 000. If you select another slot like 001, you need to format it via the Gotek. Ah, interesting. Well, it's too late because I already installed Flash Floppy on it, so we're using Flash Floppy now. So let me go to the Flash Floppy wiki just to make sure I don't screw this up too bad. Because believe it or not, Flash Floppy actually has documentation that is cogent. Wiki. I was looking at it. And let's see. Oh, let's see if there's like a default. Because you don't necessarily need a config file, but I do think I want to adjust some of the defaults. And let's see if they have examples. Yeah, this ff.cfg thing is how you do stuff. And okay, so I'm just going to drop that in here, paste it up in there, and edit that up in there with that stuff right on up in there. And I want IBM PC mode, not jumper select. So I don't want to mess with the jumper, I just want it to work. IBM PC. Host platform does not matter for us. Those are auto. Write protect. I think I'm going to go yes. Just because, you know, this is not incredibly vetted software. I don't think most of this other stuff I cared about. The only thing that I really cared about was the image selection mode, which I wanted something. There's basically, I want the mode where it just, you put file names in, and then they have this format and then it just indexes them exactly based on that naming. And there's a setting for setting that. Oh, look, it's all the display stuff for the OLED that I don't have. Ah, well. Okay, I obviously missed that setting. Oh, no, it was this. Navigation mode for selecting images, and I want default. Or not, I want indexed. So that it will pull files based on that naming scheme. And this was saved on the USB drive, right? Right? That's where I put it? Yes, good. Sure, I want to overwrite it. So, let's XVI32 this bad boy. And that looks fine. 1890FE, and then down at 1FE, 1234. So, I would friggin' hopefully expect this to actually work now. Hopefully. Maybe. We'll see about it. I just want to get this damn sector loaded. I don't even care about the non-bootable version of the floppy. We've proven that we have loaded many versions of the Bootsector and it hasn't booted any of them, so there's that case solved or tested. There we go. Oh, let me safely eject the device. Sorry, 1 second. I don't want that to be the cause of our troubles, you know? Bear with. Eject USB disk. Safe to remove hardware. Okay, there we go. Safe. Doot. Come on. Big money, no whammies. Okay. Let's see what you do. Yeah, Wareham says, from what I have read, Flash Floppy is way more flexible, especially when you need double density or single density. Yeah, I trust Dave, and Dave recommended Flash Floppy, so here we are. I think this will hopefully work a lot better. Ooh, let's hear about Cliff Cheney's weird day before we boot this thing up. Had a weird day. Found a chameleon on the street. They aren't native to Egypt. Thanks for reminding me. You're the guy from Egypt. Right. Well, you're the guy in Egypt. Had to protect it from streetcars. Probably escaped or abandoned. Now I have a chameleon. My 3 cats are perplexed. Wanted to name it Susie. Susa. Sorry. I don't know German. Girlfriend vetoed that. That's sad, because that would be a fantastic name. Does the Susa chameleon have a name? Is it just the Susa chameleon? Anyway, that's excellent. Poor chameleon. Here we go. Yay! Yay. Look at that. Because the code just hangs. So, look, it actually friggin' did it. So cool. Now let's make an image that that does not have the auto boot bit set. Look, now we're on track. This is the episode that yesterday was supposed to be. Now we can just have fun. Now this shit works. It's gonna throw a shit fit the second I try and make another disk image. No, positive. Stay positive. Stay on target. Okay. Rename. This should be the one in slot 1. Hopefully. If all goes according to plan. And then this one, let us XVI32. Choose another app. And of course XVI32 is not in the list, which is unfortunate. And I think it might even just be in my downloads folder. Yes, there we go. I like how I selected an app and it's still defaulted to Windows Explorer. Thank you very much. Okay, so all I'm gonna do here is 1FE, just replace this with 55AA, save it, and watch it not hang if I select this floppy image. Is how things should go. And if that all works out good, then boy howdy, we are setting ourselves up for being on a roll today. Make a CRC16 algorithm. But why? As much as I enjoy that kind of thing, for the gabbing before I turn this on, because that is tradition, I actually did for shits and giggles. Not that it's that crazy, but I love playing with, and you may be able to tell if you ever look at my GitHub, maybe. Actually, I don't know how representative it is of this. For some reason, like in personal bullshit code fun stuff, I really enjoy writing C for EM scripting, and like just for no good reason writing almost 100% C web apps, front end and back end, because why not? But web backend is fun in C, because all you get is a socket, and then you have to implement everything if you're not using a library, and that's fun. And at one point I was playing with, I had a game that I had written a server in Java and the front end in JavaScript, and it was just like me playing with using WebSockets to kind of implement some kind of real-time multiplayer situation, and that was fun. But then I decided, I got bored with it, and I was like, let's rewrite this whole thing in C for no good reason. And the thing is, with WebSockets, you have to implement there's a token that's sent back and forth that I think is just for anti-spoofing purposes. But in the handshake, there's a token that's sent, and SHA, that's what it is. SHA-256. Or unless SHA is just SHA. No, SHA-1. There we go. Yes, I'm confusing RSA-256 and SHA-1. So you have to, I think you receive a header with like a randomly generated base 64 string, and then you have to take that base 64 string and run it through SHA-1, and then take that SHA-1 and pack it back into a base 64 string and send it back, and if that succeeds, then the client is willing to open up the WebSocket connection. So I implemented SHA-1, and that was fun. And I need to do it again because I lost that code. I had it on my BSD system, and I think I RM'd the file like a moron. Like I RM'd the whole folder on accident, which is, I think that's happened to me maybe one other time in my life, even though they constantly warn about being very careful about that. And I have not been able to recover it. So I'm just going to have to rewrite it someday. Yes. Wareham said, well then maybe a directory listing, root directory. There ain't no file system on here, bro. We're just loading stuff off and executing stuff off the first sector for fun because we can, and implementing some kind of call dispatch in our BIOS so we can write silly things. Anyway, power. There we go. There we are. And wait for it to boot up. There we are. And this should do the normal thing. Yay, and hang. Excellent. Now, let me navigate to image 1. Come on. You can do it. Load it up. It sure is doing a lot of blinking. I don't know if that's good or bad. Okay. And this one should not hang. There we go! It's that simple. Alright, let's actually write some shit now. I'm going to go back to the ROM, and I am going to write some convenience functions. So let's do, I believe Dave was telling me, I mean, I know I could just read this myself, but I was kind of saying last time, I think I will hijack break and make that like my BIOS syscall dispatch deal instead of calling straight into things, which will make it hopefully easier to move things around instead of trying to call directly to assembled locations or, indirecting through fixed locations to get to assembled locations. So yes, which one of these is break? I think it is the last one. 65XX interrupts, because this has the nice table. And IRQ brake is at FFFE, FFFF. And what we're going to do there is, firstly, so it's this last one. And I'm going to make, I don't know, call it IRQ brake handle. And write some code there. And so basically I think we will detect if it's a brake. If it is a brake, then go into some dispatching code, and if it is not a brake, then go into some returning immediately stuff. There we go. So, what was I calling that? IRQ brake handle. I believe that was the status register. The detection of an NMI or IRQ signal, as well as the execution of a brake instruction, will cause the same overall sequence of events, which does some stuff. Boop, 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 boop. Status register. Bloody, bloody, blah. What is the thing that tells us if it is a brake? I was told there is a thing that tells us it is a brake. Program counter, put on the stack. Status register is put on the stack. What you guys telling me? What is it, says Moxia TV. And hello. Hello, Moxia TV. It is an NES booting off of a Gotek. I mean, it doesn't get more straightforward than that. We got a floppy controller plugged into this bad boy. We got a custom ROM. We're reading the first sector, and we're executing code out of it for no discernible fun reason. Hey, Trey. I guess I was going to answer your what are we doing, but I think I just did. The Gotek is set up. It's working now. Everything is fine. We're good. We just did some tests. My bootable and non-bootable versions of the Bootsector working fine. So I'm gonna implement some BIOS calls, and then we can write some Bootsector code that uses them. How about that? Anyway, how about we just Control F brake, huh? Like a smart person? BRK. Cool, 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 cool. Oh, yes. Let's see. Sure. Yes. Okay. So this is, I think, what I was being told last time. With the 6502, or the newer chips in emulation mode, the copy of the status register that is pushed onto the stack will have the B flag set, because I assume that's what that's for. So let's look at the manual. Which one is the B flag? WDC 65C02 datasheet is where I'm going to look. Not that that's the actual processor in here, but it's going to be close enough. Let's see. Do they call it the program status word in here? What do they call it? No, they certainly don't. Status register. Wow, I ended up right here. It is, oh, right here. It is 0, 1, 2, 3. It's going to be, oh, so I will mask it with 10. And if it is not 0, then we're in a break. So, what is it? Push. What is the command for push status register? Or no, that's like a transfer command, isn't it? 6502 transfer status register. Well, this works too. Transfer the thing. Let's just look for status. Oh, PHP is push processor status. Because why not? And what was the one for getting the stack? We used that. Is that not PHP? It's telling me it's PHP. Look, I'll just use it. Yeah. Okay. Cool. There we go. Nice. With bit 5 set to 1. Really? Isn't that the bit we care about? You're saying it's always going to be 1? Whatever. Look, just do what it says. PHP pull A. There we go. And then with, as I said, 10 to look at that. Look at that good old flag. And if it is 0, then handle IRQ, just in case we want to do IRQ stuff sometime in the future. Probably not. And we'll put handle IRQ here, and handle IRQ. What is the return from interrupt command? Return from interrupt RTI. That makes sense. There we go. All done. And then now we have all this space to dispatch on various things. But I'm going to read chat really quick. Hubba-dubba-dum, whoop-a-boop-a-boo. Cliff Cheney says, my first RMRF major mistake, loaner work laptop for a business trip, running QNX, because it's QNX, it is not QNX. I call it QNX my whole life. I call it QNX my whole life, but it's QNX, because it's a pun on Unix, and I didn't learn that until late in life. Running QNX live CD for fun, decided to see what RMRF/ would do. Windows partition was mounted. Oh. Whoops. Yeah. Plausible deniability on that one. Where said, I would expect the SR to tell what interrupt. You were correct. Trey Dempsey says, whoa, booting, floppy work or just Gotek? No, we're ignoring the floppy. Were you not here yesterday? Probably not. Because otherwise you wouldn't be asking these questions. No, I decided for the moment to just give up on the floppy. We will get back to it, but they've been such painful episodes lately that I just want to take it easy for the rest of this week and just make some videos where I can play. So for the moment, the Gotek provides us Bootsector information, and you know, this is still work that can be useful once we actually get the physical floppy drive working properly. So whatever. I'm just gonna play with writing booter code for fun. And Trey says, my last RMRF was a RMRF home tray sometimes. Oh, that space. Oh, chat screwed that up for me. I see. Yes, there is a space between the slash and home. Nice. Wareham said, why the PHP? I thought it is already pushed by the break command. You are totally right. Derpy derp, derp derp. And Trey said, nope, work, I'm on call. That makes sense. Okay, you are totally right, Wereworm. So, let me just see what order on the stack that is. Because if it's not the most, that wiki page totally said. And I think I closed it. I totally did. Well, anyway. Should tell me in here. BRK? BRK? You want to tell me about BRK? Because if it's not the last thing on the stack, then that sucks. BRK. BRK. I don't know what this is. I don't think that's what I'm looking for. Wait, really? That's it? That's all of the references to BRK in this entire manual? Really? Really, really, really? Is that what you're telling me? You're not going to tell me? I mean, this chart probably tells. BRK would probably be alphabetically up here. BRK. Don't tell me shit. Surely. I mean, maybe I just have to look up IRQ or interrupt stack order in general. Or I just look somewhere else. Because this is a very short document. All the memory addressing modes. Yeah, that's it. That's like this entire document. Neat. Okay, back to the wiki article. Don't need this no more. Wiki. 65XX interrupts. Nope. Wiki. 65XX interrupts. There we go. And what did they say order-wise? Yeah. Blah, blah, blah. So, address is pushed, then the status register. That's it. Okay, cool. So that is the last thing on the stack. Though I am going to have to balance this shit. That's one thing. I'm gonna have to like it's kind of silly because I'm pretty much gonna need to pull a, push a, just to make sure that the status register comes into A and then also stays on the stack. Right. Anyway, let's just start with. Ooh, that actually kinda really sucks because I want to pass my character in A. Another option that could be fun. This is a thing that is done not irregularly, and I think the place where I mostly saw and learned about this method of doing kind of system call stuff on a 6502 is AppleDOS. Is instead of passing stuff in registers, you pass you pass a. Actually, I can't even remember exactly how it works on ProDOS, but you basically pass a block of information about the stuff to be done for whichever command it is in memory. So you kind of just tell it, here's where it goes. And I think it's actually clever enough. Yeah, I think in ProDOS and oh my god, what is GSOS? Yeah, in GSOS is basically like an upgraded version of ProDOS. So I believe it's the same. And I have actually total tangent, but I really like this. Got this sucker off eBay. One of my favorite eBay purchases. I will just read this for fun. Here, 1 second. Yeah, this will work best. Apple IIgs ProDOS 16 reference. This is a kick-ass book. But yeah, this is where I learned this from. I love this book. I want to do more GSOS programming, but it's on the long list. Anyway, I'm pretty sure it's clever enough that it uses the return value from the stack to, I think you literally put the like command block right after the they might use the break instruction, and they just figure out, they use the return address +1 to load the block from, and then depending on the command, it jumps back to your code just past that, which I think is super duper clever. So I probably won't be that clever, but roughly I think I'll just like, how clever can I be? Let's pass a 16-bit pointer to some kind of like command block, wherever that may be in memory, in X and Y. Does that sound cool? Because I mean, we could just do the exact same like Protoss thing. It wouldn't really be that much harder. We just need to. We're already pulling the status register. Then the next 2 bytes on the stack are the return value. We could do the exact same thing. Let's see. Oh yeah, the NES dev page could have just told me the sequence of events. Well, you know what? I figured it out. I think it was PC low, PC high, SP. Yeah, that makes sense. And Werewolf said, or use the bit test. Let me actually do that, because the only reason that I haven't used the bit test for anything is because I don't use the bit test. Not like for any particular reason, just because I have no history of using it. And I am afraid of new things. Oh, Trey, I'm so glad you agree. He says, the 2GS, all the cool stuff that could have been in the Mac, had Apple not been so greedy. I don't know if greedy is even the right word. I guess it's a pretty good word. It's just, you know, a little short-sighted. I don't know. I like the idea of the world where the bizarro world where the 2GS becomes the direction of Apple computers. They could have been the but I mean, I don't know. I kind of like what we have. It always, I don't know. I was trying to explain this to my wife the other day, and why I find it so interesting is just the fact that, because I'm not a child of the 80s, I'm a child of the 90s, and the 80s was the tail end, and really maybe like it was the Cambrian explosion of a bajillion incompatible platforms. I guess I can remove this while I'm in here. And gabbing. Oh, wait. There we go. And it's just that we live in this very interesting world where the fact that the Mac platform exists at all is kind of fascinating. Just that you have this, that there is still an incompatible platform. Like there is no Amiga Ultrabooks out there right now. You know? I mean, technically you can make yourself a pretty sweet MorphOS machine, but the channel I mentioned last time used a trick to pass e.g. a string to the sub. He put an ASCII Z right after the jump to print instruction. Yeah, so kind of like exactly what Protoss does, I think, where it just puts it after, reads the return address, uses that, and then jumps to after the end of the payload. Yeah. Burm says, the sub increased the return address on the stack, used as a pointer, so the return jumped back to after that string. Yeah. Fuck it, man, let's just do it, because I think that is super fun. So, why the hell not? And so, between that and we'll use the bit command instruction, what have you. So, yeah, let's say that. It's just going to be, how is that going to work? We will, so the first thing pulls off the status register, and we're going to want to stash that. Maybe we just rearrange the stack a little bit. You know what I mean? So let's actually move this push A to there. So we pull it, we check to see if we're in a break, and if we are, then we hold on to it, perhaps to rearrange it on the stack. Now the fun thing is we just have to have the caller assume all the registers are getting clobbered. Because, I mean, I've already messed up A just trying to pull, so. Yeah. So anyway, maybe I'll put that in the 0 page. Easiest thing. That's always the easiest way to go, so. Store A, because our other option is, like, just rearrange the stack, put it, because we could, like, pull these values stash them temporarily and then like jam, like reconstitute. No, we'll reconstitute the stack at the end. Yeah, we'll just do that. So store store A2. Let's call it temp. Or let's call it BRK so we can organize these. BRK SR 1334. Someday I'm going to break up this file. So this is going to be BRK SR. And I'm thinking that might be no. We'll also have a 0 page relative place to store our address for things. Yeah, so I'll do that while I'm here too. So that will be at 1C, and then we'll call this BRK address is at 1D, and it was 1330 some shit. Yeah, there we go. So, yes. So we stash that, and then let's go ahead and pull A, and I think it is high-low. You know what? This article tells me it's right here. Oh no! Well, yeah, it's high then low, so reading them back is low then high. So, pull A, and then store A to... and that works, because actually, yeah, because it's low-high when we go to write it back in memory, so that's cool. So pull A, store it at BRK address, and then pull A and store it at BRK address +1. And there we go. Now we have stashed those values. So I think the next step is, let's just make, because we have to now define the shape of like our parameter block. And I mean, like, we could always just make it like a standard size, I think. I guess, I don't know how ProDOS does it, because like for that ASCII string one, that like it makes sense and is relatively easy because you're just stepping through the address, and then the address you have at the end is you can just use it. I feel like you could do a similar thing for the parameter block, where it's like your code for reading the parameter block just keeps increasing the address, but I don't want to mess with that too much, so I'm just going to use like a fixed address block size, maybe. Is that silly? Is that crazy? Nah, I'm just gonna go with it. That seems like the easy way to go. And let's just pull a number out of our ass, because we can always change it later. I'm going to go with 4 bytes. For no good reason. So, my next step is, I guess, is there a jump? Let's look at jumps, because if there is a jump relative indexed, then what we can do is like have the first byte of the parameter block always be the command, and then literally just use that to index into like a command table. Would be dope. And just put a jump table somewhere. Why am I looking in here? I should be looking in here. And we should look at all the jump commands. Oh, and I almost forgot. We got to use the bit command. So while I'm in here, I will look that up. I mean, I guess we can always... I guess we can use a jump indirect and just like calculate it in memory, as opposed to like just using an offset, because I'm not sure we can do that apparently. So let's look at the jump commands. Sure, jump to... Yes, so jump indirect. And that is 3 bytes, always. So it's not even going to be... You can't have like a faster 0 page 1, so we can put that number wherever we goddamn want. That's cool. So, yeah, I guess we'll just have another memory location where we'll have like... Like, we'll need... Oh, I guess we can get the jump table base address just from the assembler. Yeah. Is this reasonable? I don't know. But this way I can just write code where it's just like, it'll just calculate the jump table address, do a direct, indirect jump to it, and then when that's done, you know, restore the stack and increase the... That's one benefit of just having a fixed block size, is that then we can just add the fixed block size to the break address, then put everything back in the stack and call it a day. So yes, let us make up some locations. Let's load a command table, or I guess it would just be called command table, probably. That would make sense. And we want the low portion of that. Shit, let's... Okay. Make sure that it is a literal. Okay, yes. That one is low. This one is high. Very good. Oh, I'm searching for the wrong thing. Anyway, 13, whatever. Yes, so load the low part of the command table address, and oh, actually, you know what? We can load it, add the... Ooh, this is... Well, yeah. We just do an add with carry and check the carry, and yeah. That's how you do extended adds in 6502. It's fine, it's built for it. So, yeah, let's load the command table address, and then add with carry, clear carry. Load that thing, add with carry. Wait, right, shit. So we need to, because I need to load the byte from the address subsequent to the BRK address. So I'm gonna probably need to increase the BRK address to begin with. Or no, I just add 1 to the command number. Yeah. I don't know. I don't do this. Let's see if anybody says anything interesting in chat. Can't you just bit test the SP location, or would it be SP plus 1? Can you do... I'm not sure in 6502 you can, like, do stack pointer relative addressing, but I might be wrong about that. Where it says, if you pull the stack register and push it back, you'll have changed the status. Well, I mean, I'm saving the exact value of the status register, so it shouldn't change when I push that value back. Trade MC says, an M68K from 1979 cost about $15 in 1987. When did my Mac SE cost over $3,000? No color, 1 megabyte RAM, seems like greed to me, and they kept selling them with the classic. No wonder they almost died in 94. Now, that is true. That is true. Wareham says, also, be aware that break instruction might be skipped if a hardware interrupt occurs at the same time. Extra challenge. Oh, shit. That's a real possibility, because as far as I know, the video hardware is constantly putting out interrupts, and I don't think I've done anything to enable them or disable them, so they're whatever the startup default is, which is hopefully no interrupts. That would be the best. I don't need them. Okay. Right, me learning how to add things. So, come on, man. you know what? Is I can load a... Yeah, I can load a from the BRK address, then indirect. I can load a indirect from the BRK address, and then add the command table value, then add with carry. Or I need to look up how the heck that sequence works when you do an extended add. There's a process for it, and it's straightforward, but I don't know what it is. And then we'll do the bit thing. We'll do it. Yes, so let's load a... I will look this up in a second, but it's going to be something like BRK address, indirect. I don't know if that's legal, or if I have to, like, clear Y and do it indexed with no index. But anyway, then ADC, the low command table address, then, yeah, cool. Also, I don't know how many commands I'm going to support, but probably not 256. Do we want another freaking 256 location table? Actually, it wouldn't be... Oh, there's a thing. Because it's actually going to be... how do we do this? Because each entry is going to be 2 bytes, not 1. So... what's the best way to do this in that case? Is we basically need to multiply the... here's what I can do. Is I know I'm not going to support 256 commands. So we'll always lose the top bit. Who cares? Who gives a shit? And I will load this, then left shift it first. There we go. That's a thing. Clear carry. And before that, because there's logical shift right. That's a thing. Is there a shift left? Or is it rotate left? Or what is it? Shift. Arithmetic shift left. And okay, that's exactly what I want. Sick. Very good. Arithmetic shift left. And that will multiply that command number by 2. Which is exactly what we need. Because we need to skip them 2 at a time. There we go. And then we clear carry. We add the low command table value. And let's see, to store a, remember the carry value. Because I'm going to want to store this right toot sweet to we'll just make another 0-page Tempe-do. I'm sure there's probably a better way to do this by just like reusing the same address field over and over again. But I'm not gonna. Because I am sloppy. And I would rather have it work than be efficient. We can be efficient later. So let's call this command address. Sure. And that's going to be 1D, 1E, 1F. Cool. So we will add that, and then I want to store it, but let's see if... Oh, you know what? Here's a hack. Here's a mild hack that actually makes a lot of sense. So if I do that same thing again where I page align the command table, then I never have to worry about it wrapping because my number's never going to be big enough that it would wrap beyond that page. Right? So, yeah, we can just always use... we can just permanently set the high command table value. So here we can just store it to the thing that I just made, which is called command address. And then really what we'd want to do in the real world is like set this up in the initialization of the whole thing when we initialize 0 page values, but I'm just going to do it right here because I'm right here, and that's going to be load a command table high, and then store that in command address +1. And that will do that. Now command address will theoretically, I still have to implement the command table, but the command address will now contain the location into this jump table we're going to make of the actual command. And then, so I'll implement that in a minute, but here, let's add ourselves some comments. I haven't been doing that lately. Calculate calculate indirect address to jump from in command table, and cool, fine. Then the next thing would be to jump indirect. Oh, I still have to check this out too, and we still have to do the bit. We'll work backwards from here, but it would be a jump into, or should we do a JSR? No, I'll just do a jump. Or no, it's gonna have to be a JSR, you foolish man. Because we don't know where we're going from and where we're coming from. I mean, we could like jump direct back to this label, but this is probably the saner way to do it. So JSR to the command address that has been calculated, and let it do its thing and return. And then we want to clean up the stack and return from the interrupt, but let's clean up some stuff first. Is there just a relative load A without any special indexing? No, there is not, so I'm going to have to clear Y. And that's just the way it is, apparently. So let's just do that. Load Y, literal 0, load A, that. Cool. Then I suppose we can use this to step through our parameter block stuff, but whatever. Okay, cool. Then we do that. That's all clean. Then we'll do our stack restore, our return from interrupt, and create the command table. But before all that, bit. Let's learn how to use bit. Because I don't know how to use bit, and I should, because that seems like a useful thing. Oh yeah, we're gonna have bit all over here, huh? Yeah. Let's see. Command list. Bit? Hello? Bit? Bit. Test bits in memory with accumulator. Bit 7 and 6 of the operand are... Oh yeah, I remember reading about this and being slightly confused for a second because it's a little funky. Bits 7 and 6 of the operand are transferred to bit 7 and 6 of the status register, neither of which is... Wait, what are... So that's negative and 0? Wait, N and V. What? It says bit 7 and 6 of the status register, but then it shows it as... Oh, it's because these probably aren't in the order that they're in the status register. I see. Cool. I forget what V is. Oh, overflow. So whatever, I guess. The 0 flag is set to the result of the operand and the accumulate. God, this is such a weird command. So is the operand always an address of a thing to bit on? Is that what's up? Because otherwise, how could you have a 0 page and an absolute one? I would have expected the operand to just be the next byte and whatnot, but... Why would there be two versions? I hate this. I do not like this instruction. The 0 flag is set to the result of operand and accumulator. Oh. Yeah, so basically if the operand and the accumulator, then... Or if not... If the operand anded with the accumulator... wait. Right, so it's not anded with the status register, it's anded with the accumulator. So I already have to have the status register value in the accumulator to do that. No, bit sucks. I'm sorry, we're not doing it. You were wrong. Sorry. Wareroom says, I don't get it. Pull A and PHA will change what's there. Huh? Oh, no, yeah, you are right about that. So let's fix that by doing TAX, destroy X. Actually, let's not destroy too much. We know we're going to need Y, so TAY. And then, that won't be what we push back on the stack. We will TYAPHA. Yes, that was a correct call. Okay, Is there anything else terrible? Wareroom says, A is your bit pattern. It gets ANDed with specified memory location, and the flags are set, so the memory location is not changed. Right, but I can't use, like, the... There's no way to... It's a fixed memory location. It's not, like, relative. It's whatever the operand specifies that's after that, after the command byte. So I can't, like, tell it to look up the stack, the location of the stack pointer. Okay, I think we've mostly. So we assume that works all good, and then now we do our cleanup shit. So now we have to do the thing because let's see, yeah, because the address of this command block could be anywhere, unlike this command table stuff, which I can actually control, so it's aligned. So let's see, jump. Oh, I'll have to see if there's an indirect JSR too. I actually didn't check that. That would be important. Indirect call into the command jump table. There's got to be, right? JSR. All of these tables that I don't know what they're for. JSR. Nope, there is no relative. Okay, so we have to jump and then provide a return label. That's fine. BRK complete. Let's call it that. And we will just jump. JMP. Cool. And that's no longer an indirect call. Indirect jump into the command jump table. Very good. Now we'll do our stack cleanup shit, which the first thing is oh right, so this is a whole thing. This, oh my god, I just had a brainwave and it escaped me. This needs to be one more. Wait. No, this need, actually, yeah, this will work. This works, right? Because the return, the thing that's on the stack is the address right before. It's the last byte in the current command, including all operands. So the first byte of the command block is actually going to be one past that. Right, sure. Anyhow, but now we have to fix up this actual value, so let us load a BRK adder. Yeah. Yes. Ooh. Nobody called me out for this. Those need to be... Wait. No. Wait. Oh, this... every now and then this confuses the living shit out of me. It's so simple. Because I want to make sure I'm not loading from the actual address. In direction stuff. No, because break address is the address of the 0-page spot. Yes, not the value in it. Whew, I'm going crazy. So, yeah, this loads the byte that's at break address in the 0 page, which is the low byte of the break address. Wow. Come on, brains. So let's just label this real quick. Increment return address to skip over 4-byte command block. The funny thing is, all of this is probably going to be useless work if and when I start doing DOS 65, which I'm sure requires its calls to be done a certain way. Anyway, so we'll load the load address, and we will, make sure our carry is clear. And add with carry, how much? How much should we add? I guess 4? Yeah, because if it's 4 big, and we want this to be at the end of, yeah, we just add 4. So ADC literal 04, and store it, or let's see. So actually, first we have to restore. Ooh, wait. Let's change this to store Y, since our original value is there. Not the ANDed with 10 version. Cool, cool, cool. Okay, so now we'll just load this from the 0-page location. So restore status register to the call stack, or maybe higher Q stack. So load a BRK status register and push it. No, I'm doing this totally in the wrong order. That should be the last thing I do, because it should be the top thing on the stack. You foolish man. Yeah, and I can't just push this because I need to push high then low. So I have to store it back, then maybe reload them and push them. Either way, I have to do it in reverse order. Or I could stash it in Y temporarily. Maybe that's the way to go. But let's see, because the main thing is I don't want to lose my carry, and I don't know if that will make me lose my carry. Let us look. TAY. Wait, no. Wait, yes. TAY does not affect carry. I mean, that makes sense, I suppose. But so that's fine. Calculate the low return address. Stash it in Y, and then I just do another add with carry, right? Or no? Do I add with carry 0? Is that how you do it? Because it will include an extra 1 for the carry. Let's see. Oh boy. Oh boy. Where's the one that's just a link? I want the one that's just a link, you fools. I just want to go to it. What is with these tables? I never run into these tables. Now I'm running into these tables all day. What was I even looking up? Add memory to accumulator with carry. And it is not described here. That's how it works, though, right? It just, if carry is set, it automatically carries in. Lawless says hi. Hi, Lawless. Yooby dooby 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 doo. I'm just gonna look this up really quick. 6502 extended add. No. 6502 16-bit edition. Yes, of course. Boy, is this necessary. Clear carry, load the number, add it to the other number, store it. Okay, yeah, so you just... Yes, the carry just keeps carrying on. That's what I thought. And since all we're doing is we don't need to add anything higher, it's just add with carry, nothing, but the carry will cause it to add a 1 in the case that there was a carry from the low bit. Which is what I think. Then, once we've done that, now we can push, that's the high byte, and the high byte goes on the stack, then the low byte, then the status register. So, push A, then transfer Y back into A, and push A. There we go. Right, and that is the correct order as per this. Yeah? Yes, most significant, least significant status register. Cool. So I think, short of implementing our jump table, that's that, which is super cool. So let's just make a big old jump table. I think I'm going to want to... Oh, probably be good to do this part. So this actually goes way above here. This goes right after this. And then the last thing to do is actually return. There you go. And I could probably make handle IRQ and this the same code path, but get off my back. Where said, I think the first add is normal add that sets the carry, so you can delete the clear carry before, change ADDC to add, and the real... There's only... ADC is the only add command on 6502. This sounds like you may be thinking of some 68K shit, because there is no... Well, I mean, we can just scroll through the arithmetic instructions. Add with carry is the only add. I'm not going to look at that command again. Misty Wiss says, I am back. Good to see you, Misty Wiss. How long have I been going? Oh, just over an hour. Wow, I'm surprised. This has felt like it's moving kind of slow. Alright, so let's build a jump table. Got to build another one of these segments. Segment. Command table. Is that what I'm calling it? Not that that really matters, because it's the label that matters, but I'm going to have this in the label match. Command table. And then, what is it? There's, I think it's .word. Yes, I am sure it's .word. And then I think I can just put the address of a thing. So, for example, I think I could just do I could do a total hack, much like the Apple II floppy controller card ROM does. and just use another return from another command instead of making just a separate return just for the do nothing command. But I'm gonna just this is gonna be the do nothing command. Let's label these all command do nothing. We'll just jump back to brk complete, and that's that. And so I think I can just do brk complete, and I think that will store it in the right order. Let's go look at the CA65 documentation. CA65 documentation, or maybe what do they call those? Like virtual opcodes? There's a word for those in assemblers. Directives? I think it depends on the assembler and who's talking about it. I think I've heard both of those. But anyway, documentation. I can find it from here. Sure. Expressions. Scopes. Pseudo variables. Pseudo functions is what they call it in here. Word. Or is that not the thing? Control commands. Where is just byte? Let's look for word. I just want to make sure it's stored in the right order. Define word size data. Okay, that is annoying that it doesn't actually tell me. I would assume it's got to be stored little endian. Wouldn't make much sense otherwise, so let's just assume. And if shit breaks, well, we can just look at the contents of the ROM and be like, oh yeah, that's wrong. And then I'm gonna just delete that, and then 128 of those? Yeah. 128p. There you go. And what to do? Shall we just make a hello world command just to make sure our shit makes sense? Ooh, you know what? Let's make just like a hello world command just for sanity checking. Then we can do like an actual like print the string at the address I have provided you command. And let us do a return to monitor command. Yeah, this seems reasonable. So let's call this... Oh my god, I screwed those all up. I bet somebody was saying that in chat moments ago. That's not the right thing. It's command do nothing. CMD do nothing. And now 128. Nope, 120. Oh, come on, you fat-fingered son of a bitch. Dot word command do nothing. There we go. Delete 128. Paste. There we are. Okay, cool, neat, fun. Yes, sir. Don't let me forget to actually put this segment into the link configuration. But let's make 0 command command hello, and let's make this command enter monitor, and command enter monitor. I think let's just make this one. We could clean up the stack. I'm not going to be that. Actually, the stack's already cleaned up. We removed everything off of it. Yeah, that's right. I mean, it won't be clean from all of the other stuff we've done before. It would maybe be a great idea to, like, before we enter the monitor, totally reset the stack pointer, but I don't care that much. So all I'm going to do here is just jump to init and call it a day. And that's it. And then command hello. Command hello. Load the low portion of will make a string at some point. Hello. Stir. And store a to, what is that called? String pointer. And then load the high portion of our not yet existent hello stir, store a string pointer plus 1, and then JSR to print string, I suppose. Print stir. And finally, jump to break complete. Yeah, cool. I don't know. This is a lot of code for it to not all go a little bit wrong. Yeah, cool. So this is this, and if I build it and I keep our not bootable floppy mounted, it shouldn't blow up. And then we'll make a floppy that does stuff. But first, let me Utility doot. What am I looking for? I am looking for our link.cfg. And we need a segment called command table. And it's going to be a lot like LUT. So it's in the program memory. It is read-only memory. And it doesn't have a start, but it is aligned at a page boundary. There we are. Cool. You want to see this blow up terribly? I sure do. Let's build it. Let me check chat first, see if I did something absolutely brain dead, because I probably could. Misty Wiz says I will never miss a stream. Oh, don't do that to yourself. Take a break sometime. This is my after work hobby. It doesn't have to be your. Do whatever you want. I'm glad to have you either way. Where says you're right. I'm spoiled by the 68K. It's rich addressing modes. It's luxurious registers. Getting aroused. Yeah, I'm very much looking forward to doing Genesis things. I mean, everybody who works with the 68K loves the 68K. It is a beautiful, beautiful processor to program on. And the 6502 is efficient. Anyway, it's linked, right? We always do this. Gimme this EEPROM. Gimme it. And put this. Oh, wait, it didn't build. Oh, no. Oh, sad day. Segment command table does not exist. What are you talking about? Is it because I totally misnamed things and... Oh, it's probably because it didn't get that far. Because we didn't make our hello string. There's a thing. Yeah, so let's just add this to here. Hello string. Which is, oh, 1 second. I think I'm being told dinner is ready. So, 1 second. I will respond to that in just a moment. This is becoming tradition and I don't like it. Hello. Also, I should fix those /r/ns because they don't work, but... Okay. Will this link now? Cool. All right. 1 moment. Mute is going on. All right, yes, we will be wrapping it up. But that's good, because we're kind of getting to that point anyway. The next steps are burn this, stick it on there, see if it blows up, write some hex into our little floppy image there, just so that it calls hello and then dumps us back into the monitor, and then I will go. Back, ye evil monster. Okie doke. Pierogi doke. Hi, Santiago. You're missing the end of it, but this should be the fun part. I mean, it's all the fun part. Trey says 6502 is minimalism, just enough to do something interesting. No. You know what's minimalism? I mean, not to the spirit of your thing is totally correct. Sublec architectures. Yeah. One instruction. That's all you get. I've never messed around with sublec stuff, but it seems like abstraction personified, and I am totally into that. I think I'm more into the idea than I would be into actually playing with it. Okay, anyway. It's programmed, so that's good. Back into the thing you go, back into the thing you go, and you should just boot up and then not really do much of anything. Cool. That's what we would hope for. And let's just also make sure, not that we changed any code that would have anything to do with this, but go back to the old previous floppy image and just make sure that it hangs, because that's what that's supposed to do. Super cool. All right, well then, let's power this bad boy down and pull this bad boy out and start up an XVI 32 session and edit some disk. Hooty doody doody doo, yoody doo, yoody doo. What am I doing? Open with XVI 32. All right, so instead of that halt loop, what we need to do is literally it's just going to be a break, which I'm just going to look that up like a real hacker. Not even going to assemble it. Who needs that? BRK's opcode is 00. Sick. I like it. So that is 00. And then just our command block. So literally 00000000 because it's command 0 and it has no arguments. Neither of these have arguments. And then let's see. Wait, which one was which? Because I need to make sure I do them in the right order. Otherwise, we're just going to return and we won't see anything cool. CMD table. Okay, 0 is hello, 1 is enter monitor. Perfect. So a break, 4 bytes, and then a break, 01, 3 more bytes, and we should be good to not put anything after this because it should enter the monitor at that point. Should. Okay, let us safely... Oh, sorry. Damn it. I've been so bad at this lately. I'll just show you what I did again. Open with XVI 32. Okay, yeah. So, a break, then command 0, no arguments, and then a break, command 1, no arguments. That's all I was saying. All right, safely eject. Let us safely eject. No, let us not look at the weather. Let us safely eject. Because I don't want to lose any of those sweet, sweet bytes. Okay. Are you excited? I am excited. Because, I mean, this will probably go up in flames because none of this code is tested until now, but, you know... Dave popped in and said 00. Yeah. Oh, let's see. Santiago said, been caught in traffic and with some errands. Let's see what happens then. Yeah, I think you came into the perfect spot. Wereworm said, can you give a hint for what to expect for the BOS video? I mean, you know, I'm not going into these with particular plans, but I'm going to take the camera and the mic over to the Power Mac. It's currently in the middle of a Mac OS 8 install, the same one that I was doing the other day, and it's just been sitting there. And so I'm just going to complete that Mac OS 8 install and then install BOS over top of it so people can just see what a BOS install is like, because it's fun. I like the BOS installer a lot. And the Haiku installer is like exactly the same. They ripped it off purposefully and beautifully. It's a great OS installer. It's like, because most OS installers are built like wizards, and the BOS installer is just like a install the operating system dialogue. I love it. I've never seen anything else like it. I enjoy it. But anyway, so install it and then just kind of poke around in it and see if anybody has requests for what they would like me to do with it. Just going to keep it casual. Wareroom says, shall I find my BOS disks and prepare to install it myself? It has been years. You should go for it. You should prep yourself for telling me cool things that I should poke around with, because I love BOS. I've installed it on a few things in the past. It was like my first major alternative operating system that I played with, I think, because that, like the BOS 4.5 personal edition or whatever that is, that had the PC semi-install version where you could, like, I don't remember how that worked, because it put like a disk image on your Windows partition or something like that, and then your booter floppy was smart enough to be able to restore things from there and run off of that disk image or something funky like that. I remember something like that. But so that you could run it on your thingy, and yeah. Without killing your Windows installation or having to set up like a multi-boot menu or set up new partitions or anything. It was pretty clever. So yes, do that. Santiago said, wow, having an interpreter for bytecode is really progressive. Did I just invent threaded code? Did I just write a 6502 threaded code program? Because I think I did. I think technically that's what just happened. Oh my god, we should do that. Let's have the floppy code, since we're probably going to rip this out anyway, all of this work I did with this command table and whatnot, when I start implementing DOS 65, which I think I won't do until I have hardware floppy working. Until then, we're just having fun. But yeah, just have it be like, oh, that's so good. Have it be a threaded code bytecode interpreter, and all of our breaks just break into each one of those blocks is a opcode. Oh god, that would be so fun. I'm sure somebody's done that with something like this before. That's excellent. I like it. Dave says, gotta show off the hidden themes in the BOS window manager taskbar. I am. This is the first I'm hearing about that, so very excited. LoopFS mount. Yeah, that's, yes. That image, yeah, it mounted the root file system as a loop file system off of the Windows partition. Yeah, Santiago says, it's more like Java for 6502. Oh my god, I can't believe I didn't have that thought, because that's excellent. I kind of had, I think this is why it's striking me so well, is there was this little thought that crossed my mind as I was writing out that hex, and I was like, there's basically one 6502 instruction in this whole thing, and yet it's a program. Dave says, that's more like how the GBA NDS BIOS calls work. Like this way? Like this kind of like parameter block immediately following a software interrupt situation. Anyway, I do have to go to dinner. So let's see if this works. And if not, either way, I'm taking off. All right, let's go. Oh, this should be on. Come on, come on, come on. Papa wants a burger. Okay. Let's see if it says hello and drops us into the monitor. Fingers crossed. I'm 50-50. That's fun. It hung, but it didn't go off into space. All right, next time we will debug this. Sorry, I was 50-50 on it. Oh, Dave said kinda to the BIOS calls thing with the GBA, and Hypnopunk says, I just got the bell. Duh. Well, you can watch it back from the beginning. There you go. Coding Project and Stuff says GG, and on that note, I really do have to go, so see ya, love ya, and goodbye.